Hi, I'm Patrick Reagan. Welcome to the Networking Part 9 IPv6 and IPv6 Addressing. In this video, we'll discuss how host and IP addresses are signed and used. Topics include IPv6 addresses, Subnet mask, default gateway, and DNS servers. As always, stick around for the practice questions at the end to test your knowledge and help you prepare for the A+ exam. If you find this video helpful, don't forget to click the like button. And if you have not already, subscribe to the Pat Has Your Back channel for more tech training content and technical know-how. Available public IPv4 addresses are running low. There are around 4.294 billion public or global unicast IP addresses available. To overcome this problem, as well as a few others, IPv6 was developed as the next generation Internet Protocol version. IPv6 is now part of all major operating systems and is the backbone of our Internet infrastructure. Internet Protocol version 6 is the most recent version of the Internet Protocol, which is a core set of rules that govern how data is addressed, routed, and delivered across networks. IPv6 provides a number of benefits for TCP/IP-based networking connectivity, including 128-bit address space to provide addressing for every device on the Internet with a globally unique address. There are approximately 3.4 times 10 to the 38th power, or 340 unit decimal IPv6 global unicast or public addresses available. It offers more efficient routing than IPv4 and supports for automatic configuration. It also includes enhanced security to protect against address and port scanning attacks, utilization of IPsec to protect and encrypt IPv6 traffic, data origin authentication to verify the entity of the sender, which should help prevent IP address spoofing, and integrity checking to ensure data was not altered in transit. The disadvantages of IPv6 include transition period, which is due to widespread use of IPv4, which shifting completely to IPv6 will take a long time, even years. There's a communication barrier between IPv4 and IPv6 where the machines cannot communicate directly with each other. There's no backward compatibility. The IPv6 protocol is not backward compatible with IPv4, although the computer can run both IPv4 and IPv6 at the same time. There are conversion challenges where IPv6 inability to uniquely identify each device on the network makes the transition from IPv4 time-consuming. Because IPv6 uses 128 bits, the address is usually divided into groups of 16 bits, written as 4 hex digits, where each hexadecimal number represents a nibble of data. Hex digits are based on 16 digits, including 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, A, B, C, D, E, and F. The groups are separated by colons. An example is shown on the screen. Similar to the IPv4 addresses, IPv6 is divided into network bits and host bits. The first 64 bits define the network address, and the second 64 bits define the host address. For our example, FE80:00:00:00:0000 defines the network bits. 02C3:B2DF::FEA5:E4F1 define the host bits. Initially, the network bits are further divided where a block of 48 bits is used as the network prefix, and the next 16 bits are used for subnetting, which allows up to 65,536 subnets. The recommended IPv6 address division includes an ISP prefix, which is 32 bits assigned by the upstream provider, customer site prefix, which is 16 bits, which defines the customer site or organization under the ISP, Subnet ID, which is 16 bits used by the organization to divide their site into multiple subnets, an interface ID, which is 64 bits, which identifies the specific host or interface on the subnet, which is required to be 64 bits for Slack. 0000 can be written as just 0. If a block is set to 0 and is followed by another block set of 0, it can be written as : Some examples are shown on the screen. With IP version 6, unicast addressing can be divided into global unicast address, which is the public addresses that are globally routable and reachable on the IP version 6 portion of the internet. 2000::/3 starts with the binary value of 001 through E000::/3, which starts with the binary value of 111. Unique local addresses, or ULA, is meant for private addressing, with the addition of being unique so that joining two subnets does not cause address collisions. They start with FC00::/7. Each ULA prefix is unique with the global IP version 6 address space, ensuring no conflicts when different sites or organizations. These addresses are not routable on the global internet, but are routable internally. They're designed for private networks, enabling communications within a site or between a limited number of sites without requiring internet connectivity. Linked local addresses are private, non-routable addresses confined to a single subnet. They start with FE80::/10. They are used for communications between devices on the same physical or logical link, like a local LAN or VLAN. They're used by hosts when communicate with neighboring hosts on the same link, including Neighbor Discovery Protocol, or NDP, and automatic address configuration, but can also be used to create temporary networks for conferencing or meetings, or to set up permanent small LANs. Devices automatically assign themselves linked local addresses through a process called linked local address auto-configuration, also known as auto IP or stateless address auto-configuration. Since many interfaces may use the same linked local address range, the operating system must know which interface to use. At the end of the linked local address, you'll find the zone index or interface identifier, which tells the operating system which network interface the address is associated with. In Windows, it might proceed with something like %13. In Linux, and it might end with %ETH0. Without this index, the OS or device wouldn't know which interface's linked local address you're referring to. In Windows, to see which number goes with which interface, use one of the following commands: the get net IP interface from PowerShell, or net sh interface IP version 6 from the command prompt. In Linux, use the IP addr show, IP-6 route show, or IP-6 addr show scope link. If you see a preferred at the end of an IP version 6 address, the address is fully usable for sending and receiving traffic, which can be used for initiating outbound communications. If you see a valid at the end of the address, it's still usable for receiving traffic, but it should not be used as the source address anymore. If marked deprecated, it's still technically valid, receivable, but should no longer be used as the source for outgoing connections. This is governed by the preferred lifetime and valid lifetime and IP version 6 address configuration, typically provided by Router Advertisements, or RA, during Slack, DHCP version 6, and manual configuration. The IP version 6 loopback address is : ::1. Similar to IP version 4, for an IP version 6 host to communicate on a network, it typically needs an IP address, which is unique logical address assigned to the host, a subnet prefix length, which specifies which bits of the IP address is network bits and which bits are host bits, a default gateway, which is the IP address of the nearest router, which allows communications with each other's networks, and DNS server, which is the IP address of a DNS server, which provide name resolution to IP address. When manually configuring IP version 6 in the Windows TCP IP version 6 settings, you'll configure a unicast address, either global unicast or ULA, depending on whether the address is meant for internet routable or internal private use. Again, here is the ipconfig/all command showing the IP configuration. In IP version 6, the DHCP server is used for address assignment and configuration of other network settings, just like in IP version 4, but with some differences depending on the mode in use. There are two main forms of DHCP for IP version 6 or DHCP version 6 modes. Stateless DHCP version 6 provides only additional information like DNS and domain search list, while the IP address is assigned via SLAAC. Essentially, there's use with SLAAC, whereas router advertisement provides the address and DHCP gives the extras. Stateful DHCP version 6, similar to IP version 4 DHCP, provides full IP address assignment, lease tracking, and config options. It's useful in managed networks that require tracking of leases and host information. Stateless address auto configuration, or SLAAC, is a method for IP version 6 clients to automatically obtain IP addresses and other network configuration information without manually configuration or a DHCP server. It's also known as IP version 6 auto configuration. It determines the IP prefix using Neighbor Discovery Protocol, or NDP, router solicitation, or RS, and router advertisements, or RA. Instead of using a DHCP server, it relies on router advertisements sent by routers. The host generates an address based on its own interface identifier, usually based on the MAC address or a randomly generated number, and combines it with the router's advertised prefix to form a full IP version 6 address. No separate servers keep an estate, which means no tracking of IP or MAC addresses, and lease times don't exist. By default, SLAAC can use the host MAC addresses or EUI64 format, which is a privacy-invasive privacy extension. If you're concerned with privacy tracking, you can use a stable randomized identifier, again without any centralized tracking. It uses duplicate address detection, or DAD, to ensure that no duplicate addresses exist on the network. Instead of DHCP-like lease times, SLAAC uses lifetimes advertised in router advertisements. Types of lifetime include the valid lifetime and how long the address is valid, which is usable for communications, and preferred lifetime, which is how long the address should be used as preferred before deprecation. These lifetimes are included in the RA along with each advertised prefix. Once the preferred lifetime expires, the address is considered deprecated and is still valid but should not be used for new connections. After the valid lifetime expires, the address is invalid and must be removed. Question: how many bits in an IP version 6 address? Answer: 128 bits. Question: what type of address is shown on the screen? Answer: IP version 6 address, specifically a global unicast address. Question: what type of IP version 6 address is a public address that is routable and reachable on the internet? Answer: global unicast address. Question: what is the successor to IP version 4? Answer: IP version 6. Question: You have the following IP version 6 address shown on the screen. Which of the following is the proper shortened version? Answer: EF82 1AB1 1234 1BC2. Question: You want to assign addresses for IP version 4 and IP version 6. The DHCP server only supports IP version 4. What can you use to assign IP version 6 addresses without DHCP? Answer: Slack. For more information, refer to these sites. In summary, IP version 6 provides a number of benefits for TCP/IP based networking connectivity, including 128-bit address space to provide addressing for every device on the internet with a globally unique address. Because IP version 6 uses 128 bits, the addresses are usually divided into groups of 16 bits written as 4 hex digits. A global unicast address is a public address that are globally routable and reachable on the IP version 6 address portion of the internet. The IP version 6 loopback address is : 1. For a host to communicate on a network, it typically needs an IP address with a unique logical address assigned to the host, a subnet prefix length which specifies which bits of the IP address is network bits and which bits are host bits, the default gateway, which is the IP address of the nearest router, which allows communications with other networks, and the DNS server, which is the IP address of a DNS server, which will provide name resolution to the IP address. Stateless address auto configuration, or SLAC, is a method for IP version 6 clients to automatically obtain IP addresses and other network configuration information without manually configuration or a DHCP server. Thank you for watching this video. The next video will be networking Part 10 DNS services. If you like this video, don't forget to click the like button, and if you have not already, subscribe to the Pat Hedger Back channel. Thank you.